Now we're going to be looking at complex numbers. Now, complex numbers, what it is that it has a real part. At this moment, every number we have known is a real number. So it has a real part, but it also has an imaginary side. So it has a real side and an imaginary side. So that's what we're going to call it complex numbers. Now, there is an imaginary number. We call it I. So we're going to use I for imaginary. The interesting part of I is that it is the square root of a -1. Now we're going to use I to get the square root of negatives. So I is the square root of -1. So that means that I to the second power is -1, right? If I was to square both sides, I get that I to the second power is equal to -1. All right, so this is going to be very interesting. Now, let's take a look at something here. Write each number as a product of a real number in I. So I see I have the square root of a -100. So let me split this as the square root of -1 times the square root of 100. I know the square root of -1. I just said that is I. The square root of 100, that's 10. Now, I10 kind of looks a little hard to read. So when we have an I and we have a number, we tend to write the number first. So my answer in this case will be 10I. Now let's take a look at example B. Let me take care of the radical first. So I have that as the square root of -1, the square root of 36. So I know that the square root of -1 is I know the square root of 36 is 6. So generally I will write that as 6I. Now because of the negative sign on the outside, I'm asking for -6I in this case. Now let's take a look at example C. Let me break this as the square root of -1, the square root of 2. I know the square root of -1 is I. The square root of 2, I cannot simplify that. Now in this case, I said when we have a number, we put the number on the front. However, when we have a radical number, we try to keep it after the I. I'm going to show you guys in the next slide why. So when we have a radical, we put the I at the front. All right, let's take a look at example D. Let me break this as the square root of -1. I'm I'm taking the negative sign out. And then square root of 8. Let me simplify if I can. So I have the square root of -1. Right, there's not much I can do on that one. I can call it I. But at this moment, let me call it the square root of -1. Now the square root of 8, I'm going to break it into 2 square roots. I know my perfect squares. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. So I must choose a number from the right side. I'm going to call it 4 times 2. So I know that square root of -1 is I. The square root of 4 is 2. And then square root of 2 just stays the square root of 2. Now to write this a little bit better, I'm just going to write this as 2I. Remember, when there's a whole number and an I put the whole number first. Radical 2. Now this is for you guys to try at home. And this should be your answers. Now the reason why when there's a radical, we put the I at the front, because it's easy to, if I put at the end, it's easy to mistake radical 2I, especially we tend to write our radical sign way too long. It's easy to misunderstand whether the I is inside the radical or outside the radical. So we can, like say, if we tend to write a radical sign too big, it's hard to see the difference. We don't know the I is inside the radical or the I outside of the radical. That's why we write the I in front of the radical. Now, one thing that we must do also when we have multiplication, that's a rule that we're going to use. Do not multiply -4 and a -9. Don't do the square root of -4 times the square root of -9. Don't do that. Instead, so don't do that. Instead, see it as the square root of -4 by itself and then the square root of -9. So let's take a look at an example. Like I said, I'm not going to multiply my numbers on the inside. I'm going to see each of them individually. So I'm thinking, oh, the square root of -4, I see that as the square root of -1 times the square root of 4 times, I have to do the square root of -1, the square root of 9. So from the first part, we can just say that I call this 2i times, we can say I call the second part 3i. So I have this. Now when I multiply it, I have 6i to the second. I know I to the second is -1. So in general, I have this as 6 times a -1. So I'm just going to call this -6. When I see example B, I have the -1 times +3. So I'm going to call this I radical 3. I cannot simplify my radical, but at least I can take the negative sign out as an I. On my second part, I'm just going to simplify that as I radical 7. I cannot simplify the radical, but at least I can take out the I. So this is, let me combine my radicals. This is radical 21. Because they're positive, I can combine them now. Then I have I to the second on the outside. Remember when we're multiplying letters, we just add the exponents. Now we know that I to the second is -1. So I'm just going to call this negative radical 21. Let me take a look at example C. Let me call this I radical 2. Right, the way I broke this up, I have this as -1. I factor the -1, so that gives me I radical 2. Now for the second part, I have the negative sign, and then I have this as 4 times 2. So that's going to give me, from this first part, that gives me 2i radical 2. Now in multiplication, let me deal with the numbers, quote unquote, the whole numbers. So I have I times 2i, that it gives me 2i to the second power. Now the radicals, radical 2 times radical 2, that gives me radical 4. I multiply my numbers, but then the square root of 4 is a whole number. That becomes 2. Now they're whole numbers, so let me multiply everything. I have 4i squared, better known as -4. Now let's take a look at example D. I'll factor the negative sign. Here I have radical 6. So I have that I radical 30. I cannot simplify radical 30, so that is as simple as I can go. Once again, do them individually. So I call this I radical 4, I radical 9, which my answer was -6. If I would have multiplied, if I would have said, you know what, let me multiply the numbers on the inside, I get the square root of 36, which is 6. Notice how my answers do vary. That's why I said when it's negative, do not just multiply the numbers inside the radical. Do not. All right, so here, this is for you guys to try it. And this is This is your answer. This should be your answers. Now let's take a look at this. Do not divide 75 divided by 3. And do not divide that. You might get the answer, but that would just be luck. So let's take a look. I'm just going to have this. I know the square root of 75. I'm just looking at the number. Remember, I have the I on the front because it's the square root of a negative. But I know I can call that square root of 25 square root of 3. I wanted to have it such that one of them is a perfect square root. Now the bottom part, because it's the square root of a negative, I know I'm going to have the I on the front, square root of 3. Cannot simplify that anymore. Now the interesting part here is that I with I cancel out, square root of 3 with square root of 3 cancel out, so I just have the square root of 25, which is 5. It is on top, so it's not a fraction. Now, if my square root of 25 was at the bottom, let's say I cancel everything, my square root of 25 was at the bottom, I will call that 1 over 5. I cannot leave the top empty. But in this case, the square root is on the top, so it is a whole number. I'm not going to write it 5 over 1. It's just 5. Now, for example B, because of the negative sign inside the radical, I'm going to call it an I. Now, square root of 32, let me break that as square root of 8, square root of 4. Or better yet, square root of 4 times the square root of 8. I wanted one of them to be a perfect square. It doesn't matter, which order we put them. Now at the bottom, I have the square root of 8. Interesting is that my square root of 8's cancel out. Square root of 4 is a perfect square. So let me just call this 2i. All right, square root of 4 is 2. It's I. When I have a whole numbered in I put the whole number first. So this is for you guys to try. You can always pause the video. And those are the answers. Now, I said a complex number. It has a real part, no I in it, and an imaginary part, which has an I in it. When we write them, we have to have a plus or minus in it. We tend to write the real part first and the imaginary part second. The real part is the one that doesn't have an I. The imaginary part is the one that does have an I. So what do we have to look at our numbers now? Real numbers is everything you knew so far. Like irrational numbers are the numbers that are radicals that are not perfect squares. Rational numbers, you have radicals but are perfect squares, repeating decimals or fractions. And then you also have your integers, your whole numbers, and your natural numbers. Now we're adding the list of complex numbers. And that's basically all the numbers that we have at the moment. Now let's add them. Let's add complex numbers. So I have an imaginary part and a real part. What I'm going to do, let me write each of these without the parentheses. So my first parentheses, let me just write it as 2 plus 3i, right? Without the parentheses. My second parentheses, let me call this plus 6, right? It's a positive 6, plus 6 plus 4i. Once again, I'm writing everything without parentheses. And I'm just going to combine my like terms. I know I have a real part, any number that does not have an I. So I'm just going to say my real part is 8. And the imaginary part is anything that has an I. I'm just going to add the numbers. So I have 8 plus 7i. That easy. Let's take a look at example B. My first parenthesis, I'm just going to write 4 plus 2i. My second parenthesis is a positive 3, so I'm just going to write plus 3 minus I. And for the last parentheses, I'm going to write minus 6, that is a negative 6, plus 3I. Once again, write everything without parentheses. This is when we add or subtract. Now let's take a look at the real part. Anything that does not have an I. So I have 4 plus 3 minus 6. Now 4 plus 3 minus 6 is 1. Now let's take a look at the imaginary part. Everything with an I. 2 minus 1 plus 3. That should give me positive 4I. Don't think there's a catch to this. It's really this simple. This is for you guys to try at home. This is what you guys should have. In addition, it is this simple. Now, on subtraction, there's just a little twist. It's not too hard. The first parentheses, we're going to write it as it is. So 6 plus 5I. Now, because of the minus in between the parentheses, I'm going to distribute it to the parentheses that comes after. So every time I have a minus, so I'm subtracting complex numbers, the negative sign, I distribute it to the parentheses that comes after. So let me call this minus 3 minus 2I. Notice I distribute the negative sign. Okay, so now let me just combine like terms. I look at the real part, those that don't have an I, so 6 minus 3, I'm going to call that 3. Now when I see the imaginary part, 5 minus 2, I'm going to call that plus 3I. Same thing with example B. My first parentheses, let me just write 7 minus 3I. Because there's a minus sign, I distribute it to the parentheses that comes after. So I'm going to call this minus 8 plus 6I. Notice I switched the signs, including the one with the 6I. I changed it to positive. All right, so now let me combine my like terms. When it comes to the real part, 7 minus 8, that gives me negative 1. When it comes to the imaginary part, negative 3 plus 6, that gives me plus 3I. Let's take a look at example C. Negative 9 plus 4I. Because of the minus, let me distribute to the parentheses that comes after. So it's going to give me plus 9 minus 8I. Let me take out the real part. Negative 9 plus 9, that's 0. So I'm not going to write this. When it comes to the imaginary part, that gives me negative 4I. Some people like to write this as 0 minus 4I just so they can see the real part. I'm okay. When it comes to paper, I'm okay either way. We tend to go with the just negative 4I. It doesn't have a 0. So this is for you guys to try at home. And that should be your answer. Now, what if we multiply? Let me multiply the 4I to the first term. I'm just going to multiply numbers with numbers and letters with letters. So that's going to give me 8I. Let me multiply 4I with the 3I. That's going to give me plus 12I to the second. Now, we talked a few slides ago that I to the second was negative 1. So 12I squared basically is negative 12. Right? I to the second power is negative 1. That's why I call this negative 12. Now, when we write this, I'm going to write this as negative 12 plus 8I. The real part first. Now, let's take a look at example B. Let me distribute the 3 from the first parentheses. So that's going to give me 12 minus 6I. Let me distribute the 5I from the first parentheses to the second parentheses. That's going to give me plus 20I minus 10I squared. I know the minus 10I squared at the end is basically plus 10. So now when I combine my real part, those that don't have an I get 22. When I combine the imaginary part, negative 6 plus 10, negative 6 plus 20, I get plus 14I. Lastly, let me take a look at example C. Let me distribute the 2 to the second parentheses. So that gives me 2 minus 10I. Now let me distribute the 3I to the second parentheses. That gives me 3I minus 15I squared. Now the negative 15I squared at the end, that is basically plus 15. So when I see the real part, those that don't have an I, 2 plus 15, I get 17. When I look at the imaginary part, negative 10 plus 3 gives me negative 7I. Now this is for you guys to try at home. Now, what if we have an I at the bottom? We have to get rid of it. Well, what if we have a plus sign at the bottom as well? I'm going to multiply it. We did this with radicals. I'm going to multiply top and bottom with 5 minus 2I. Basically multiplying by 1, right? The top and the bottom of the fraction are the same thing, so I'm multiplying by 1. Do notice that my plus sign, I changed it to minus. So switch the sign. If it was a minus to begin with, I would have changed it to plus. Now let's take a look on the top. Let me distribute the 8 to the second parentheses. So that's going to give me 40 minus 16I. Once again, I'm just working the top. Now let me distribute the 9I. It's going to give me plus 45I minus 18I squared. Now minus 18I squared, I'm going to call that plus 18. I'll leave it at that for the moment. Now let me worry about the bottom of the fraction. Let me distribute the 5. That's going to give me 25 minus 10I. Now let me distribute the 2I. That's going to give me plus 10I minus 4I squared. Two interesting parts. The two terms in the middle, they cancel out. The end, negative 4I squared, just going to call that plus 4. Okay, so looking on the top, so for my fraction, looking on the top, let me combine the real parts, those that don't have an I. That gives me 58. Let me combine the imaginary parts, those that do have an I. Right, 45 minus 16, that gives me 29. At the bottom, 25 plus 4 gives me 29. Now, I can simplify more if my numbers, my whole numbers, I can divide them all by the same thing. So I'm looking at 29, 29, and 58. If I can divide them all by the same thing, then I can simplify. Let me simplify by dividing each by 29. So this becomes a 2, 1, and 1. Now the one at the bottom, I'm just going to ignore it, so it's not a fraction anymore. So I'm just going to simplify this as 2 plus I. All right, 2 plus 1I. It's not a fraction anymore. All right, let's take a look at example B. Let me just multiply top and bottom by I. What I'm interested in is getting rid of the I from the bottom. I know I times I is going to get rid of the I from the bottom. So let me take a look. Let me multiply the 2 on the top. It's going to give me 1i plus I squared. Now when I multiply at the bottom, I get I squared. Now on the top, I squared is basically -1. Remember to write the real part first. So I'm going to call that -1 plus I. At the bottom, I just have a -1. If I divide everything by -1, I'm just going to have 1 minus I. Right, 1 minus 1i is just basically 1 minus I. I have at the bottom of the fraction, so that's why it stops being a fraction. If it was not a 1 at the bottom, obviously it will remain a fraction. Now for you guys to try at home, your example B will be a fraction. It is okay if B, you guys end up writing this as 15 plus 10i all over 13. It is the same thing. So if that's what you guys have, that's what you guys have. Now, consider the following cases. I to the 1, just one I. I'm just going to call that I. I squared, we said that is -1. Now, I to the 3rd, that is basically broken as I squared times I to the 1. I know what I squared is. I know what I to the 1 is. So that basically gives me -I. I to the 4th can be broken down as I squared times I squared. I know I squared is -1. So I have -1 times -1. Basically +1. Let me take a look at other cases. What if I have I to the 5th? That is basically I to the 4th times I to the 1. I know I to the 4th is 1. You're going to see it from my previous list. That is basically just I. I to the 6th is I to the 4th times I squared. I know I to the 4th is 1. I squared is -1. I to the 7th, I'm going to call that I to the 4th times I to the 3. Basically 1 times -I. I'm just going to call that -I. I to the 8th, let me call that I to the 4th times I to the 4th. 1 times 1, which is 1. Now, something very interesting. Notice how my i's repeat. My -1, my -I, and my 1. So if I was to go I to the 9th, I to the 10th, I to the 11th, and I to the 12th, I'm pretty sure my answers would be I, -1, -I, and 1. So my powers, my answers will always be I, -1, -I, and 1. Every time. And notice that I have 4 possible solutions. So basically multiples of 4. Because I4 has the same multiplicative property as 1, right? Any powered of I with an exponent that is a multiple of 4 has a value of 1. The same thing with I to the 0, because that's the multiple of 4. So what I'm going to do when I have something really, really big, my exponent, let me subtract multiples of 4. Right, let me subtract my exponent any multiple of 4. I want to make sure I know what's I to the 1, I to the 2, I to the 3, and I to the 4th, right? We came out with that list on the previous slide. So I want to subtract or add multiples of 4 such that I finish with I to the 1, I to the 2, I to the 3, or I to the 4. So let me subtract an 8. I to the 12th is the same thing as I to the 4th. Once again, let me add or subtract multiples of 4, such that I finish with I to the 1, I to the 2, I to the 3, or I to the 4. Now from the previous slide, I to the 4th, we said it was 1. So this is 1. I to the 39, let me subtract, in this case, 36. Once again, I'm adding or subtracting multiples of 4. So that's going to give me I to the 3. Now from the previous slide, I know I to the 3 is negative I. Now for example C, let me add a 4. Remember I said add or subtract multiples of 4. That gives me I to the 2nd. So this is negative 1. Here, let me add a 4. That gives me I to the 3, which is just known as negative I. Now, for homework, we can even give you something really, really quote-unquote hard. 530. The hundreds are multiples of 4. So I will start by subtracting 500. That will give me I to the 30. So much easier. All right, subtract the hundreds. Once again, hundreds are multiples of 4. Then from here, I will subtract 28. That will give me I to the 2nd. So I to the 530 is better known as negative 1. Right, I to the 2nd is negative 1. So this is for you guys to try at home. Now this is my moment to be a little nerd. Now you guys will understand certain jokes that you guys see outside. Square root of negative 1. That's just an I. 2 to the 3rd. It's a number 8. Now this Greek letter, you guys don't know it. It's called sigma, which means addition. So let me just write the sum. And then this number pi. So if you read that, it says, I ate some pie, and it was delicious. All right, we wear t-shirts like these sometimes. Then a joke that we have a lot is the I is telling the pi to be rational, because we know pi is irrational. It's a decimal that never repeats. But then pi is telling the I to be real, because it's an imaginary number. Now you understand some of our jokes. All right, make sure if you guys have any questions, make sure you guys contact me.